T-distribution, as we've vaguely talked about before, is a family of probability distributions, and Z is part of that family. The T-distribution depends on something called degrees of freedom, which we'll talk about in a little bit, but the degrees of freedom determine the shape. So in this picture so far, we have the Z distribution in the black line, and you can see here that we have 2.5% in the tail, and the critical value is at 1.96, extremely close to 2, right? And the T with 1 degree of freedom, the smallest degrees of freedom that we can have. Degrees of freedom are whole numbers, 1, 2, 3, 4, etc. Remember, the Z is the T with infinite degrees of freedom. And so this is a T with 1 degree of freedom and 2.5% in the tail, and the critical value is at 12.7 odd, and it's way off the picture. Let's change degrees of freedom. Okay, so now we have 2 degrees of freedom, the Z stays the same, and as you watch, you'll see 3, 4, 5, 6, 7, 8, 9, 10 degrees of freedom. You'll see that as the degrees of freedom get larger, the T-distribution starts to get real close to the Z. As close as the T-distribution might get, though, the critical value is still off, right? So we can scroll through, and statisticians usually stop at around 30, and at 30 degrees of freedom on the T, they'll say that the T with 30 is approximately equal to the Z, and we can see that. And beyond that, we really don't need any more finesse on the critical value. So at 30 degrees of freedom and more, we'll approximate the T with the Z. But below 30 degrees of freedom, we will use the appropriate T distribution. Okay, so we have a rule here that says if the degrees of freedom, df, are less than 30, we'll use the T with so many degrees of freedom and do the small sample test. These are for averages now. Or alternatively, if the degrees of freedom, which we have yet to define, but it's different in different situations, it's greater than or equal to 30, we'll approximate with the Z, T with infinite degrees of freedom, and do the large sample test. So up to this point, we've been doing large sample tests, and hopefully when you go back and test the degrees of freedom, or look at the degrees of freedom, they'll all be greater than or equal to 30. For one sample averages problems, the degrees of freedom is sample size n minus 1. It's very simple. But as we do different types of tests later, the degrees of freedom will change. For 2 sample tests, and later on, way down the road, for regressions, degrees of freedom will be different than just n minus 1. Alright, so that's the background. Beyond that, reading the T distribution works the same as we've done before. Let's have a quick look. Alright, so here's the T distribution tables. We have degrees of freedom 1, 2, 3, 4. It scrolls, let's scroll it down. You'll see it go 28, 29, and then it just skips over to the Z, the infinite degrees of freedom. So at 30 or more degrees of freedom, we will approximate with a Z. Anything else, and we will use the appropriate line on the T distribution. So if we had a 10 degrees of freedom and wanted 2.5% in the tail, alright, 10 degrees of freedom, this line, 2.5% in the tail, would use a critical value of 2.228. If we had 5 degrees of freedom and we wanted 5% in the tail, we'd use 2.015, etc., etc. And that's all there is. Okay, the formulas that we'll use in the one sample tests, small sample tests, will be the same, except now instead of calling things only Z, we will use same formula, but call it T-calc. Alright, x bar minus mu divided by the standard deviation of the sampling distribution S of x bar. Alright, so theoretically what we called Z-calc before is T-calc, but since Z is a particular T, that was no big deal. And remember, all of this is done for only averages. For proportions, the only tests that we will do are large sample tests, and so there will always be the Z. By the way, proportions, small sample would sort of break down and become a binomial, and we cannot use the T for the proportion. So small sample tests for averages. So now when we have an averages problem directly after the hypotheses, the next thing we'll do is to check the degrees of freedom. Okay, this in the one sample case, or another formula in the two sample case, or more later. Okay.